Okay, ladies and gentlemen, during next coming 2.5 hours, I'm not going to tell you anything about UniMET, SOS, Martel, no good or better or best practices, but I will talk about us and our very best friends, namely authorities, stakeholders, and Santa Claus. I'm coming from Satakunta University of Applied Sciences. I worked there, like I corrected yesterday, as a bridge engineer. I have roots of navigation and bridge systems, even though teaching automation, ship electricity, safety and reliability and things like that. But nevertheless, we have the same and common goal everywhere within this consortium with no name. I'm not going to tell the name over there. To have a safer and better training in future. All right. Some facts about Finland, looking as a maritime point of view. The population is a little more than 5 million, including Santa Claus. Santa Claus is not coming from Sweden, it's coming from Finland.
Sure?
Yes! And the one who doesn't believe don't get any presents this Christmas. Out of those 5.5 million, we are 92% Finnish speaking and roughly 6% of Swedish speaking people, and then some minor parts, other languages. In the maritime sector, we have 2 universities of applied sciences, 2 for Finnish speaking, 2 for Swedish speaking. And vocational maritime training centers are also 2 for Finnish speaking and 2 for Swedish speaking. So Satakunta University of Applied Sciences includes today almost the European oldest maritime academy, next to Willem Barents, I guess, or somewhere in the same range. We have just 130 years anniversary here.
You can show it, can't you, as you shape?
Yes, over here. Each one of the seafarers who has sometimes sailed up to road, perhaps also in winter traffic, knows where Rauma is. Everybody knows where Finland is because Santa Claus is coming from there. There are 3 major cities in the whole wide world. There is Rauma, Rome, and Paris. Yeah, and if we look at this, our campus, which is, we have the maritime neighbors. We have Port of Rauma. Throughout that port is some 6 million tons goods coming, import, export, 200,000 TEUs of containers. We have STX, Rauma shipyard over there, very next to us, over here, in this area. If the school is here, the shipyard is over here. We have Rolls-Royce producing Aquamaster, all Rolls-Royces today. The azimuth propulsion system, steel prop, same kind of company over there. We have Finpilot piloted, of course, working actively on this area. We have the Coast Guard district, which is located over there. So we have a very close contact with all these stakeholders over there, as well as the authorities elsewhere. Institute is partner or member at least on IMCA, IMU, PINCO, NTS, and being involved as a partner at least on my knowledge, Surpass, UniMET, UK. All right. And many others to come, let's hope so. We look forward in being in good company and doing better work. We have got the STCW audit, which was refreshed very recently. the watchman and both of the watch officers. If we look at the education structure in Finland, generally speaking, we have the first step, which is the preschool and compulsory, starting from age of 6 years and ending around 15 years. Then we have the second step, which can be splitting out to an upper secondary school, ending up to a high school graduation, or vocational school, producing the skilled workers on different professions. And that will take 3 to 4 years. We also have in vocational school today a combined system that you both graduate from high school and get a profession. And that will last always for you. Those very tough guys and tough girls, and they are doing quite fine in that. That can be something which has confused sometimes, that we have something which is kind of combination for both. It is both vocational school and upper secondary school. And then further, after graduation, for example, you go to university degree or high school or upper high school degree. It takes 3 to 4 years. In addition to that, to get the bachelor degree, and additional 2 to 3 years to get advanced university degree, just like master or so. And then, depending on time, money, wife, and family, etc., people can go on doing their licentiate or doctorate degrees by the time. This fall, when we started the season, we have one doctor in physics, which joined our academy, starting to be a perhaps master of the ship sometime. Young, very skilled lady, doctor in physics. All right. If we look at the study structure of our school or schools, generally maritime schools in Finland, it is divided into 4 or 4.5 years if you look at the calendar years over there. So both tech and engine part, and after the 3rd grade or 3rd year in school, depending on the practical training, etc., people can have their qualification as operator on watch or operator on engine watch. If we look at something history, like I said, I'm bridge engineer, I need to come into the bridge system a little bit. Still in late 70s, most of the bridges for new buildings, even for new buildings, were designed and furnished with standalone equipment. No integration, no intelligence. Radars and all the other sensors, they were used, but no electrical connection, except the primary power supply. No signal. We were discussing about signals, controlling the signals today's operator. Otherwise, the signals are controlling the operators. No input-output ports, no interfacing. Just main units and control units. And then what happened? Research and development in components, computer technologies, etc. brought some benefits to maritime business too, even though we are very conservative, long-term changes, etc. First commercial ARPA was introduced in 1969 by Norcontrol. Some of the seniors might remember this kind of equipment. Breakas 1 was very advanced, late 70s. It had even target tracking and 7 synthetic drawing lines to be presented on the screen. Imagine, that was good old days. But what to do? We had whole bunch of interesting navigation data available. Signals, speed from log, position from different sensors, heading from gyro in various kind of formats, depth from echo, And then interfacing started very slowly. Manufacturers added their input-output ports on rear panels and created their own standards, proprietary systems. Homemade converters need to be done, interface boxes need to be done, and they spread it out like what? They were hanging like tropical lianas in the jungle. That was very challenging. You made retrofits on the bridges, brought something new, how to interconnect that with the existing things. I'm not talking about how to upgrade the operators to use them and get the best benefit out. Interface work came as a swear word until common understanding was found with NMEA. It made possible not only to purchase and install, but also interface navigation systems more easily to get better outcome out of the system. Today, we have network integrated navigation system. It has climbed up to the bridges, and we have double bus connections, fiber optics, things like that, even approved by the classification societies, etc. An operational act related to watchkeeping requires still the human operator, despite the automation. Somebody has said that even the monkeys can drive or sail the boat, or sail it safely. Is the other thing. We have orbiting satellites, high-speed data whatsoever. Transportation of goods cannot be done virtually by the satellites or broadband lines. Even they are available today, but they can support the safe navigation of the assuming that people know how to use the technology. And that is our task, my friend, to see that our training plans will follow slow by slow. We have a new generation climbing up to the bridges. How to keep them there? They are used to play these tic-tac-toe machines, etc. Let's see that we follow with our training plans so that they will remain happy with them. Okay, training is lifetime project. We have a basic training, STCW, been discussing, been not arguing, but is it following, is it fast enough to the changes? Resource management, different kind of refreshing courses, tanker TP, chemical tanker, special courses, short courses, etc. Is it enough to teach the cadet as per today? We need to look at the movement, all of us, together with our good old friends, authorities, stakeholders, etc. I'm not going to go through further this, what I have introduced when starting as a bridge engineer or starting as a deputy principal lecturer in there, but as part of the master studies, we have example of one course. Yesterday we discussed about these courses and making the cross-reference list. It is a course named Integrated Bridge System. It is intended for 6 nautical officers, cadets, or other bridge team members with responsibilities in navigation operation to work with integrated navigation system. And the target is to gain general understanding and operation of the system, strengthen the knowledge of the system configuration and application, reading and understanding the operating manuals, documentation, using, and fault-finding instructions provided for INS on possible failures. That is, generally speaking, the goal. We do know that carriage requirements and performance standards, they are well defined by IMO, IEC, ISO. Classification societies have given their own standards, and we have examples of different configurations and applications that we go through from the very beginning, before we go deeper into this integration. These students have gone through already the basic navigation equipment of navigation sensor courses 2 years before. So this is on the 4th grade. We start now talking about integration. And we go throughout the processes and safe operate, not looking what individual sensor is doing, but what processes are using what sensor data and how it is duplicated or so. We look at the interconnections and data transfer before the sensors and INS, example of failure analysis, trying to create a failure situation on simulator, and use the documentation and fault finding procedures as much as possible with today's tools, with today's simulators, etc. And in addition to the complexity, the exam, they have already been participating and gone through courses like shipbuilding theory. I'm not talking about captains, coming captains, ship electrotechnics, power plant, engine room automation, etc. What is this? Okay. Okay. The ruling, navigation world ruling, we know that there are ruling and guiding, IMO, IEC, etc. Flag authorities are there in between, trying to follow what the upper level IMO and classification societies have said. Do they follow? Do our training follow the time? Maritime authority field in Finland is fragmented, unfortunately. We used to have one-stop shopping, Finnish Maritime Administration, that's it. One door shopping, or one-stop shopping, until 1st of January 2004. Today we have 3 different offices to handle it. Trafi, Liikennevirasto, Viestintävirasto, which means Transport Safety Agency, Ship Safety Control, Port State Control, etc., etc. Transport Agency, competent authority for VTS, fairways, and winter traffic. Communication authorities follow radio licensing, ROC, GOC, endorsements, etc. Just a jungle. Lianas hanging from there and there and there. We happen to know somebody from past who used to work with FMA, but where to find him and who is today doing and what is doing. Not to mention of individual seafarer, if he needs to do something. All right. Despite the fragmented structures, all them authorities and stakeholders in maritime sector do support these projects. We can tell. Finnish ship owners, Finnish Maritime Society, labor unions, shipyards, etc. They all are here in the expected to see the coming results. Where do we go? STCW needs to be refreshed to follow today's technical requirements, coming technical requirements. Do we need system administrators on the bridges and in the engine control rooms? Can software engineers sail or navigate a vessel today or tomorrow? That was Sauli Ahvenjärvi's question sometimes. Let's not be afraid, but let's be prepared.
Thank you.
Thank you all.